Last question. A wheel spins in a counterclockwise direction. You can see based on here that we have a unit circle, so that's significant. Fill out the table below showing how P travels when the wheel makes each rotation. When the wheel makes each rotation. So we have counterclockwise rotations from positions shown and the distance P travels in feet. Remember from a previous lesson, we learned that the distance P travels in feet is equivalent to the angle in radians. So basically what we're going to figure out is when we make 1/3 of a full rotation, what is that angle going to be in radians? When we make 2/3 of a full rotation, what is that angle going to be in radians? So on and so forth. So let's start with 1/3. I'll find it in degrees and then convert it to radians. So 1/3 of a full rotation, so that would be 1/3 of 360 degrees. So 1/3 of 360 degrees. I'm just going to use the calculator on my phone to do that. So 1/3 times 360 is 120 degrees. Okay. 2/3 times 360 degrees. So if that would be the second row there. Is 240. And we know that a full rotation, one full counterclockwise rotation is 360 degrees. So the answers that will go in the table are just going to be us converting these to radians. Now we already know that 360 degrees, we've proven this in a past lesson. We know that 360 degrees is 2 pi radians. So that will go here. 2 pi radians. Now we just have to convert 120 and 240 degrees to radians. So let's do that. So we're going to convert 120 degrees to radians. And that's going to be 2 pi over 3. So 120 degrees is 2 pi over 3 radians. So that's what's going to go here, 2 pi over 3. 240 degrees. So let's do that one. So convert angle 240 from degrees to radians. That is going to be 4 pi over 3. So this one will be 4 pi over 3. So we filled in the table. So we've done part A. Part B, we've actually already answered. What angle measured in radians, does the point P travel through when the wheel makes 2/3 of a complete counterclockwise rotation? So 2/3, we said that was 4 pi over 3. I just took that from up here. So there's your answer for part B. Part C, explain why the distance the point P travels is the same as the angle of revolution measured in radians of this wheel. Okay? It has to do with the circle being a unit circle. Okay? That is the reason why it works. So because, to answer the question, explain why the distance the point P travels is the same as the angle of revolution. Because the circle is a unit circle, distance is equal to the angle in radians. So that is the reason. Okay? The distance is equal to the angle in radians because the circle, the wheel, is a unit circle. Okay? And that is it for number 8, and that is it for the study guide.